Alright, this video involves more graphing. Sort of like I did the last time, I'm going to graph myself a function, and I'll go through and look for things like absolute and local max and mins, where is the thing increasing, where is it decreasing, all that kind of stuff. So here's the function. F of x equals x times the square root of 7 minus x squared. First thing I'm going to do is to determine the intercepts, x and y intercepts. Start, of course, for me at least, with the x-intercepts. So set x times the square root of 7 minus x squared equal to 0. And then you have two different solutions, x equals 0, that's pretty obvious, or 7 minus x squared equals 0. Now this square root is really easy to solve. All you have to do is square both sides, and you'll get rid of the radical. So you'll have 7 minus x squared equals 0. Add x squared to both sides. 7 equals x squared, and then take the square root. So x equals plus and minus the square root of 7. It's about as easy as it gets. So we have our intercepts. The x-intercepts at least. Let me do the y-intercepts. What do you do for the y-intercepts? You just plug in x equals 0, that's all. So look at f of 0. That's 0 times the square root of 7 minus 0 squared. Well, that equals 0. So the y-intercept is actually the same as one of the x-intercepts. When x equals 0 is an x-intercept, well, 0, 0 is automatically going to be a y-intercept. Remember, you only get one y-intercept on a function. So in all, my three intercepts are 0, 0, and plus and minus radical 7, comma 0. For the domain, the x that's on the outside of the square root can be anything, so there's no restriction on what x can be based on that. However, inside the square root, whatever's in there, we have to take and make sure that it's greater than or equal to 0. So that's what I'm going to try to solve. Now first, before I do anything, let me show you some of the things that students do. I have no idea where they learn to do this, but some of them actually try to solve this thing the same way they would do an equation. So subtract 7 from both sides, then multiply through by -1, so it'll change the orientation of the inequality symbol. But then they'll do something that is absolutely mind-boggling. Take the square root of both sides, but then put plus and minus. X is less than or equal to plus and minus radical 7. What is written right there makes no sense. How can it? It must be bigger than one of them and less than the other one, I think is what you mean. That is not a correct statement in any way, shape, or form. I don't know how bad it is, but I know when I run across it, I put a big old X through it. So, in fact, this is so ugly, so bad of an algebra that we want to delete it from ever being on the page. I don't even want evidence of it ever having existed. So what is the correct way? Well, factoring is the correct way. I still do like I did before, 7 minus x squared is greater than or equal to 0, but then I use something like a difference of squares method to factor this. Now, in previous courses, that may not have been considered factored because of the radical 7s, but in the real numbers, a lot more things factor than just the stuff that factored over the integers. Anyways, so the two zeros are highlighted on a number line. Notice that between and to the left and to the right of those zeros, that the function is going to be one sign over that whole interval. So from negative infinity to negative radical 7, the function is going to be, or at least this expression is going to be all negative or all positive. So let me throw in -5 and see what happens. If you throw in -5, look at the first half. You get radical 7 minus -5. So that's radical 7 plus 5. So that's a positive number. Then, if you plug it into the other piece, you get radical 7 minus 5, which is a negative number. So you have the product of a positive number and a negative number. So together, that will make negative. Now pick something in between negative radical 7 and radical 7. The easiest thing to pick is always 0, so let's use that as my test point. Plugging in 0, I'll get radical 7 minus 0 times radical 7 plus 0. Well, that's just 7, and that's definitely positive. To the right of radical 7, I will choose 5, I guess, sort of like before. I'm pretty sure I'm going to get minus, but let me put them in anyways. Radical 7 minus 5 is negative. So that first piece is negative. Radical 7 plus 5 is positive. So you have a negative times a positive, and that results in a negative. Now remember, since I'm in the square root, I want greater than or equal to 0. So my domain will be between negative radical 7 and radical 7. And I will include negative radical 7 and radical 7. So the domain is the closed interval, negative radical 7 to radical 7. Now if you remember, this function is continuous on that interval. That means it definitely has an absolute maximum and an absolute minimum. Moving on. The critical numbers. Those are the places where, if you'll recall, the derivative is either equal to 0 or the derivative does not exist. And these are only points in the interior. Like you wouldn't worry about taking the derivative of plus or minus radical 7, for example. Those are endpoints. So we want points inside where the derivative is 0 or does not exist. So let's start with the function and take its derivative. Use the product rule. F prime of x is going to equal 1 times the square root of 7 minus x squared plus, now leave x alone, times the derivative of a square root is 1 over 2 square root. And I'll put my insides in. But the chain rule says I have to take the derivative of 7 minus x squared. So let me do that now. So we have the square root of 7 minus x squared. I think what I'll do is take that derivative first before I start simplifying. Don't get too excited to simplify. And I am simplifying because I will be using these answers later on. So that derivative was negative 2x. So I see that I can take out a 2. The minus will come to the front of all this, and I get the square root of 7 minus x squared minus x squared over the square root of 7 minus x squared. Now you're supposed to set that equal to 0. And this is amazingly easy to solve. Multiply both sides of the equation by the square root of 7 minus x squared. Watch what happens. On the first part, square root of 7 minus x squared times itself is going to just yield 7 minus x squared. Square root disappears. It's even better on the next one. When you multiply it through, it will cancel with the square root of 7 minus x squared in the denominator and will leave you with just x squared. Now this is very easy to solve. You have 7 is going to equal 2x squared. Divide by 2. And take your square root. Don't forget plus or minus. So x equals plus or minus the square root of 7 halves. So what we want to do is, well, first find the y values of each of these things, because we will be using that as part of our answer. If you remember, this function was x times the square root of 7 minus x squared. So I have radical 7 halves times the square root of 7 minus radical 7 halves, and the square root of 7 halves is squared. So that gives me the square root of 7 halves times the square root of 7 minus 7 halves. And so that gives me the square root of 7 halves times the square root of 7 halves. Well, that's not, that doesn't happen very often. So you'll get 7 halves. So what was the other one? Negative square root of 7 halves. That equals negative square root of 7 halves times the square root of 7 minus the negative square root of 7 halves, quantity squared. And I'll write the details here, but I believe you're going to end up with negative 7 halves. I guess I'm not going to write the details. I think you can handle the details. So these are the 2 points found using setting the derivative equal to 0. Let's write these down. Negative square root of 7 halves, positive, or negative 7 halves, positive square root of 7 halves, comma, 7 halves. Those are our 2 points. And to try to determine if they're going to be max or mins or whatever, however way we want to look at it, let's make up a number line and mark off the zeros of the derivative on that number line. Those, of course, were negative square root of 7 halves and positive square root of 7 halves. And we want to do just like we did before, try test values in between and outside of these numbers to determine where the derivative is positive or negative. So I'll pick a number to the left of negative radical 7 halves. I'll pick negative 5. So I'm just recalling what the square root was. Let's throw it in here and see what we get. So we have the square root of 7 minus 5 squared minus 5 squared divided by the square root of 7 minus 5 squared. I'm keeping this error in, and I wonder if you know why. What I didn't take into account was that the domain itself only goes from negative radical 7 to radical 7. So I could never have picked negative 5 as a test value. I have to pick a number between negative radical 7 and negative radical 7 halves. So with that in mind, if you try to strain your brain a little bit, but negative radical 7 halves is a little bit bigger than negative 2. So I'll plug in negative 2 into the derivative to see what it is on that interval. Now these work obviously a lot better. Square root of 7 minus 2 squared minus 2 squared over the square root of 7 minus 2 squared. So we get 7 minus 4 over the square root of 7 minus 4. Square root of 7 minus, I don't know, nope, just put 3. Square root of 3 minus magic. I made an egregious error, so I just cut it all out. That's why the stuff suddenly jumped on the screen. But the important thing to recognize is that it's first decreasing for the outer interval, then it's increasing in between, and then it's decreasing thereafter. And so from this, you should be able to get something of a graph. I have the points. Let's go ahead and just draw something rough. No big deal. Remember, I'm going to check this with the computer anyways, but I'm going to show you how much you can actually discern about the graph just based on these numbers. First thing, let's lay down the places where the function is 0. Those were at negative radical 7, 0, and radical 7. Now then I had a couple of points that I found using where I set the derivative equal to 0. So let me sort of estimate where they are. Remember, this is just a rough sketch, so getting it exact is not exactly that big of a deal right now. So let me throw my numbers in. I had a... All right, make sure you catch this little error because you'll see the wrong thing there. I don't know why I put that square root in there, but it doesn't belong. The square root of 7/2 belonged on the x-axis. Anyways, I had one number, what was it? It was negative radical 7/2, negative 7/2. That's the lower left. And then the radical 7/2, 7/2 is in the upper right. Let me fix my graph a little bit. You can see how they're working. And these are going according to the way it said because I'm decreasing first, then I'm increasing, and then I'm decreasing. Got all my zeros. So that's not such a bad graph. I mean, if there's more details, we'll uncover them later in the course, but that's not really such a bad graph. You have a lot of details in there. Now, how does it compare to the real thing? Let's pull in a graph done on a computer and see how it looks as opposed to my graph. No, outside of a bad drawing on my part, they represent pretty much the same thing. All the numbers, if you look really carefully there, I'm putting a dot where the radical 7/2, 7/2 is. And you can see that the 7/2 is right on the money. Then you've got the rightmost x-intercept that happens at radical 7. And then we have the a minimum here at negative radical 7/2 and negative 7/2. So in fact we have a highest and lowest y value, which I said would happen because the function's continuous and it's a closed interval that we're dealing with. So those points are not just local mins and maxes, they're absolute mins and maxes. What's the range of y values that we have? Negative 7/2 up to 7/2. And let's see, it's increasing in the middle. Now you list the x values for this. So when you say it's increasing, you write as an open interval, comma, or I'm sorry, parenthesis, negative radical 7/2, comma, radical 7/2. I usually do not use closed intervals for this stuff. Decreasing, it's on the first and last intervals. So on the first interval, the x values that it's working on is negative radical 7 down to negative radical 7/2. Union. And then we have the x value at the other max, at the other extrema is radical 7/2, and that'll go up to radical 7. Now, if you would have included the endpoints here, negative radical 7 and positive radical 7, I'd have been all right with that because the function is definitely decreasing at those particular places. As I mentioned, this is not just a local maximum, it's also an absolute maximum. The other point is a local and absolute minimum. So 7/2 is going to be the absolute maximum value. Negative 7/2 is the absolute minimum value.